Hello students, in previous class we discussed about modern periodic table and we discussed about groups and periods. Do you know in that groups we discussed names of the family names, chemical family, like that. Means first A group elements are called as alkali metal family, second A group elements are called as alkali earth metal family, third A group elements are called as boron family, and fourth A group elements are called as carbon family, fifth A group elements are called as nitrogen family, sixth A group elements are called as oxygen family, seventh A group elements are called as halogen family, eighth A group elements are called as noble gas family. So do you know how are the names of the certain families of periodic table derived? Now we will discuss. Okay. First one is alkali metal family. So here alkalis means plant ashes. Okay. So alkali means plant ashes. So alkali means plant ashes. Sodium and potassium etc. were obtained from the plant ash group 1A element, so are called as alkali metal family. Okay, so here alkali metal family, how this name was derived for the first group elements. Here alkali means plant ashes, sodium, potassium etc. were obtained from plant ash, so group first A elements are called as alkali metal family. Next, chalcogen family. So sixth A group elements are called as chalcogen family. How this name derived to that sixth A group elements? Here chalcogenous means ore product. Okay, chalcogenous means ore products. So as the elements in the group 6th A from ore with metal, form ores with metals. Okay, so this chalcogenous means ore products. So as the elements in group 6th A forms ore with metals, so they are called as chalcogens family. Next, halogen family. So seventh group elements are called as halogen family. So how this name is derived? Here halos means sea salt. Okay, halos means sea salt. Okay, genus means produced. Okay, so halos means sea salt, genus means produced. So as most of the elements in the group 7th A are obtained from the nature as sea salt. Okay, so most of the salts, most of the elements in the group 7th A are obtained from the nature as a sea salt, so they are called as halogen family. Next, noble gases. As the elements of a group 18 means 8A are chemically least active, so they are called as noble gases, and their outer shell configuration are basis for octet rule. So what is octet rule we will discuss in next chapter. Okay, now we will discuss about metals and non-metal. Okay, what is our next topic? Metals and non-metals. Okay, you have learned about the properties of metals in the chapter metals and non-metals in class 8th. Okay, in 8th class we learned about the metals and non-metals in 4th chapter. Okay, let us study the metallic properties of elements in periodic table. So now we will study the metallic property of elements in the periodic table. So how which are metals, which are non-metals, we will discuss in the periodic table. The elements with 3 or less electrons in the outer shell are considered to be metals. Okay, the elements with 3 or less electrons in the outermost shell are called as metals, and those with 5 or more electrons in the outermost shell are considered has to be non-metals. Okay, so in the outer shell 3 or less than 3 electrons are there, okay, then that element is called as metal. If in a element in its outermost shell 3 or less than 3 electrons there in that outermost shell, then it is considered has to be metal. Okay, next those with 5 or more electrons in the outermost shell are considered has to be non-metal. In metals, in its outer shell more than 5 electrons, okay, more than 5 electrons, 5 or more than 5 electrons are there, so then we can call that it has a non-metal. For example, sodium is there. Sodium atomic number 11, its configuration 1s2, 2s2, 2p6, 3s1. So in last shell 1 electron there, no, so then we can call this as a metal. Okay, magnesium is there. So what is this atomic number 12, electronic configuration 1s2, 2s2, 2p6, next 3s2. In last shell how many electrons are there? 2 electrons are there, so we can call this also as a metal. Okay, like that. Okay, in outermost shell if 3 or less than 3 electrons are there in the outer shell, then that element is called as metal. Next, non-metal means which have 5 or more than 5 electrons in the outermost shell is considered as non-metal. Means for example, take oxygen. Oxygen atomic number in outermost shell 5 or more than 5 electrons are there in the outermost shell, then it is called as non-metal. For example, oxygen is there. Oxygen atomic number 8, its electronic configuration 1s2, 2s2, 2p4. So in this last shell, which shell? Second shell. Okay, so in the second shell how many electrons are there? 2s2, 2p4 means 4 plus 2. Total how many electrons are there? 6 electrons are there. So then we can call this as a non-metal. Next, nitrogen. Nitrogen atomic number 7. Okay, its electronic configuration 1s2, 2s2, 2p3. In last shell how many electrons are there? 2s. Last shell is second shell, no? In that how many electrons are there? 2s2, 2p3 means 3 plus 2, 5. Total 5 electrons are there, so then we can call this as a non-metals, like that. Okay, so in last shell 3 or less than 3 electrons are there in the outermost shell, that is called as metal. In last shell 5 or more than 5 electrons are there in the outermost shell, it is considered as non-metal. So we may find some exceptions to this. Okay, so D black elements, third group to 12th group are metals and they are known as transition metals. Okay, so this D black elements means third group to 12th group are metals and they are also known as transition metals, and the metallic character of D black elements decreases gradually from left to right in the periodic table. Okay, so these D black elements means third group to 12th group are known as metals and they are also known as transition metals, and the metallic character of these D black elements decreases gradually from left to right in the periodic table. Next, lanthanides and actinides actually belongs to third group, means third B group, which is within the transition elements, hence they are called as inner transition elements. So here lanthanides and actinides, that lanthanides actinides that are separately at the bottom of the periodic table, no, but that are actually start from. So we may find some exceptions to this. Next, D black elements third group to 12th group are metals and they are also known as transition metals, and the metallic character of this D black elements decreases gradually from left to right in the periodic table. Next, lanthanides and actinides actually belongs to third group, third B. Okay, these are belongs to third group, third B. So which is within the transition element. Okay, hence they are called as inner transition elements. Okay, lanthanides actinides actually belongs to third group, third B group, which is within the transition elements, hence they are called as inner transition elements. So why? Because some scientists suggested that lanthanides are lanthanum to ytterbium, means 57 to 70, 57 to 70, they will say like this, okay. And some are suggested like this, cerium to lutetium. So and some take lanthanum to lutetium. These 15 elements, these are called as for the lanthanides. Some scientists suggested that lanthanum to ytterbium, means lanthanum 57 is there, no, that one, okay. That lanthanum to ytterbium, and some suggested them as cerium to lutetium. Cerium what, here 58 is there, lutetium 71 is there, cerium to lutetium, these 15 elements, okay. So finally, and some take this lanthanum to lutetium, means 57 to 71, 57 to 71, lanthanum 57, no, and lutetium is 71, no. So these are the taken as a lanthanides, okay. So this lanthanum, it is in the third B group, okay, third B group. Next, at the same time, also in the case of actinides, there are different arguments, like actinides are from thorium to lawrencium, means thorium, its atomic number is 90 and this lawrencium atomic number is 103, okay. So these they took as actinides, okay. But another take actinium to lawrencium. Actinium to lawrencium means actinium 89 and lawrencium 103. Up to this they took as actinides. So this actinium also, it is in the third B group once you observe the periodic table, okay. So this lanthanides and actinides actually belongs to third group, so which is within the transition elements. So that's why these are called as inner transition elements, okay. So the elements with the the elements in outermost shell, 3 are less than 3 electrons, then that we can call them as a metals, okay. Next, the elements with the outermost shell, 5 are more than 5 electrons in the outermost shell, that are called as non-metal. But we may find some exception to this, exceptions to this. D black elements, means third group to 12th group is there, no, that are metals. And so D black elements third group to 12th group are called as metals, and they are also known as transition metals. And the metallic character of D black elements decreases gradually from left to right in the periodic table. And lanthanides and actinides actually belongs to third group, third B group, so which is within the transition elements. These D black elements means third group to 12th group, that we can call as a transition metals. But this lanthanides, actinides also belongs to third group, means third B group, means here lanthanum, it is in third B group. Actinium, it is also in third B group. Lanthanum 57, it is in third B group. Actinium 89 also, it is in third B group, okay. So means these are also in the transition means this third B group, this third group to 12th group are called as transition elements, no. This lanthanides and actinides also actually belongs to third group, third B group. So means within the transition elements only it is there, hence they are called as inner transition elements, okay. Next, metalloids or semi-metals are elements which have properties that intermediate between the properties of metals and non-metals, means metalloids will be there. These metalloids also called as semi-metals. These are the elements and which have the properties that intermediate between the properties of metals and non-metals. Metalloids that have the properties like metals and non-metals. Okay na? So means they possess the properties like metals but brittle like non-metals. Okay, so metalloids are say metals that are having the properties like metals and non-metals. Okay, so which like means the metals having the met so okay, metals having the like sonorous, ductile, malleable, good conductors of heat and electricity, like that will be there, no? So here also these metalloids, they have the property like metals but that brittle like non-metals, means that have these metalloids having the property like metals and it will break easily like a non-metal. So they are generally semiconductors. Okay, they are generally semiconductors. Example: silicon, germanium, boron, these are the example for metalloids. Okay, so all elements in S block are metals. Okay, so in the periodic table we classified the in the periodic table we arranged the elements. How we arranged the elements in the periodic table? And outer the differentiating electron, means the last electron entering into which orbital by depending on, okay, the last electron entering into which orbital, by depending on that we can classify that as a first group, second group, third group, like that. Means once again I will explain here. Once you observe the periodic table, if you observe the electronic configuration of hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, in this hydrogen electron entering into hydrogen atomic number 1, its electronic configuration 1s1. Okay, means last what is coming, s1 is coming. Lithium atomic number 3, its electronic configuration 1s2, 2s1. Last what is coming, s1 is coming or not coming. Okay, sodium atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s. Okay, 1s2, 2s2, 2p6, 3s1. Last one is coming or not, s1, like that. Next, potassium atomic number 19, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. s1, like that it is coming or not? Yes, it is coming. So here the last electron is hello. Okay, hello. Okay, so here the all okay, so see here, metalloids are semi-metals are the elements which have the properties that intermediate between the properties of metals and non-metal. Say they possess the properties like metals and that will break easily like non-metals. So they are generally semiconductors. Example: boron, silicon, germanium, like that. Okay, so all elements in S block are metals, whereas P block are whereas P block are metals, non-metals, and metalloids. And in the periodic table, do you table you will notice a staircase like demarcation. The elements to the left side of this demarcation are the metals, and to that are the non-metals. So the elements on the staircase are very near to it are like boron, silicon, arsenic, germanium are the metalloids. Okay, so see here all elements in S block. Do you know which elements belongs to S block and where has it, and which elements belongs to P block? Okay, I will explain now once again. Once you see the periodic table, so in that periodic table hydrogen atomic number is 1. Okay, its electronic configuration 1s1. Finally s1 is coming. Okay, next, lithium atomic number 3, its electronic configuration 1s2, 2s1, 1s2, 2s1. Finally s1 is coming or not coming. Sodium atomic number 11, its electronic configuration 1s2, 2s2, 2p6, 3s1. s1 is coming or not? Finally outermost configuration, that only called as outermost configuration. s1 is coming. Potassium 19, its atomic number 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Finally s1 is coming or not? s1, it is coming. Okay, so like that if you observe the electronic configuration of the elements which is in the first group, finally s1 will come, but its front number, principal quantum number is changing. Means hydrogen 1s1, lithium 1s2 2s1, sodium 1s2 2s2 2p6 3s1. This three like this changing, this 1 2 3 that is changing, but last differentiating electron configuration it is not changing. S1 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 is will come. That's why these all are called as first A group elements. Next, if we observe the second A group elements, okay, so beryllium atomic number 4, its electronic configuration 1s2 2s2, last electron entering into 2s2, okay. Magnesium atomic number 12, electron configuration 1s2 2s2 2p6 3s2, s2 is coming, means s2 is coming, okay. Calcium atomic number 20, configuration 1s2 2s2 2p6 3s2 3p6 4s2, it is also entering into s2. Principal quantum number is increasing, but finally it is entering into s2 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 s2, yes or no? It remaining also it will come like that only, finally s2, okay. So once you try to write the configuration and see it, okay. So it is an so here s2 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 coming, that's why this we can call as a second group elements. And this last differentiating electron entering into s orbital, no, that's why this first A group and second A group are called as s black elements, okay. Next, at the same time, once you observe the third A group, boron atomic number, boron atomic number is 5, okay. Its electronic configuration 1s2 2s2 2p1, okay. Boron atomic number 5, its electronic configuration 1s2 2s2 2p1, okay. So here last electron entering into p1, no, last electron is entering into p1, so that's why it is called as p black element. Carbon, observe atomic number, carbon atomic number how much? 6, electron configuration 1s2 2s2 2p2, 2p2 means last electron into p orbital, no, that's why it is p black elements. Nitrogen atomic number 7, okay. So nitrogen atomic number 7, electron configuration 1s2 2s2 2p3 p3, last electron entering into p orbital, that's why it is p black elements. Now we will discuss about